Alright, so we're looking at expected value today, okay? Before that, we're just going to talk about probability distributions, okay? So, 4 coins are tossed, X is the number of heads obtained, okay? 3 dice are thrown, X is the number of sixes obtained. Down here, 1 person is selected at random, X is the height of that person. 1 person is selected at random, X is the IQ of that person. X is called a random variable, okay? So it depends on chance. It depends on however many heads happen, depends on chance. So that's the random variable. Now, in these ones, it was the discrete random variable. And down here, weight, height, and so weight and height then would be continuous random variable, okay? We're only interested in discrete random variables at the minute, all right? So if ever you see that X, it's basically the outcome, and the outcome depends on chance. All right, that's what a random variable is. Now, down here, if X is the number of heads obtained, a table of the results can be formulated as follows. Okay, so 0 heads, 1 head, 2 head, 3 heads. And then your probability of getting 0 heads, so I'm flipping 3 coins here. Okay. Probability of getting 0 heads happens here, that's 1 out of 8. Probability of getting 1 head happens here, here, and here, so that's 3 out of 8. This is called a probability distribution. It's just a table, okay? A table showing all the probabilities. So we're going to use those things now, okay? Our heading is expected value. Now we have this spinner here, okay? 4, 8 and 12. The expected value would be, what is the average that you're going to land on, okay? If I find out the probability of 12 is what? A half. Probability of 8 is a quarter, and 4 is a quarter, okay? Probability of 12 is a half, 8 is a quarter, 4 is a quarter, all right? If I average out multiplying these two, that's the expected value. So 12 by half is 6, 8 by quarter is 2, 4 by quarter is 1. Add them up, 6, 7, 8, 9. The average is 9, okay? This starts to make sense when you think about this as being a game, all right? It might cost me €10 to play the game. So it costs me €10 and I can either win 4, 8 or 12. Now if it costs me €10, I figure out my expected value, which was 9. Expected value means if I play the game a large number of times, on average my winnings will add up to 9, okay? So on average I'll get €9. So if the game costs €10, but my winnings on average would be €9, should I play the game? No. That's what expected value is. Okay? You're using the expected value of something to decide whether a game is fair or not. For a game to be fair, you'd have to get 0. You don't want to win money, you don't want to lose money. The game is fair is if you get 0. Your expected value isn't 0, but the price of the game would be 10, and your expected value would be 10, so you would win or lose nothing. Then the game is fair. Does that make sense? Yeah? So, if we actually do a question, before that I'm just going to write the formula for expected value. Now I wouldn't bother learning it or even using it really, okay? Because we're just going to do exactly what we did. We're going to multiply the probability by the outcome and add up my answers, okay? But it is do you remember what that symbol means? It's the sum of, okay? So the sum of the outcome x by the probability of x, okay? So the outcome x by the probability of x. You're adding up. So you multiplied the probability by the outcome, and then you're adding all of those up. Okay, and E of x is the expected value of x.
Do we take it down?
You can take it down if you want, just so that you're used to the terminology, but...
Can you write down your words? Like you said?
Oh yeah, sorry. The sum of all the probabilities multiplied by their respective outcomes. Okay?
What do you mean by respective?
So if the outcome was 4 and the probability of getting a 4 was a half, it would be 4 by a half. It means the ones that relate to each other. So 4 is with a half. That's their respective outcomes. Okay? Okay, so let's do an example. It costs €8 to spin this wheel. Find the expected value and determine whether the game is fair. So normally what we do is we do out a table for ourselves. Your outcome, your probability, and then when you multiply the two of them together. Okay, so your outcomes are 4, 5, and 10, and then their respective probabilities. What's the probability of 4? A quarter, 5, a quarter, and 10, half. And then you're going to multiply them. Okay, so 4 by a quarter is 1, 5 by a quarter is 1.25, and 10 by a half is 5. Now your expected value happens down here. It's when you add up those Is that game fair?
No.
No. And on average, how much would you expect to lose? Yeah, 75 cent. Okay, so you're taking them away. Basically, expected value tells you if I spun this a large number of times, on average, I'd expect to lose 75 cent per game. Okay? So this, they didn't ask me that in this question, but you can still write it down. So okay, so on average you would expect to lose 75 cent on each spin. And the last sentence you're going to write, this game is not fair. Okay, this game is not fair.
Did you have to write that?
Because they actually asked, determine whether the game is fair, yeah, you should write the sentence then. Okay. You okay with that? Yeah?